Go. Okay, we're doing our online competition practice today in period 7. So let's get started. First problem says let f be a function given above. Which of the following is true about f? Does the limit exist? Let's check the left-hand limit. The left-hand limit would be plugging in 3 is equal to 8. The right-hand limit is going to be 8. The right-hand limit is 8. So therefore, this is true. Is f continuous at x equals 3? Well, since these are both polynomials, they're lines, and it's defined at 3, it's continuous because the limit of that is equal to the function's output at 3. So that's true. They're both 8. Is f differentiable at 3? Well, we could see that one has a slope of 1 and one has a slope of 3. So when these things come together, when x is 3, one has a slope of 1, one has a slope of 3. We could obviously see that it's not differentiable because it's a cusp. So this is a false. So where 1 and 2 are true. So we're going to select D as our answer there. D. Okay, moving on. Problem 1A. This style of this problem is a limit as it goes to 0. That's the key, as it goes to 0. So remember the sign of u over u, as the limit of u goes to 0 is 1. But this is the sine cubed of 3x. So I need basically a 3x here, and I need it cubed. Well, I already got the x cubed, but I plugged in a 3 cubed, so I need to put a 3 cubed up here to balance this part out. Okay, I balanced it out now. So I look at what's left. This limit here goes to 1, and what's left is 3 cubed, which is 27. Okay, so that's problem 1A. Let's go to 1B. Okay, with a style of problem like this, I want to break it down into sines and cosines. So here's x, here's 1 over cosine, and here's cosine over sine. I notice that my cosines reduce, and I'm left with a pattern of x over sine, and as that limit goes to 0, that's going to be 1. So I'm looking for 1 here. Okay, 1C, let's turn the page. I notice I'm going to look to factor out of this difference of 2 cubes. I'm going to get x minus a over x minus a. And what's left is going to be a quadratic, which would be x squared. And my last term is going to be plus a squared. I always kind of forget what to put in the middle here. So I think it's ax, I think. So I'm going to multiply x times ax, that's positive ax squared. And then if I multiply here, negative a, let's see, what do I do? X times all those, yeah. And then negative a will be the opposite of that. Does that make sense? No. Yeah, this is negative ax squared. And then I get a positive ax squared, so they drop out. So that's correct. Okay, so I cancel out my 2 factors, and I'm now substituting in a because the limit goes from x as it approaches a. So I'm going to say a squared plus a times a, which is a squared, plus a squared. And notice I have 3a squareds downstairs, so that's going to be c. Okay, got it. Let's move to the next problem, 1D. Okay, I'm going as x approaches 0 of this quotient. I can't just plug it in, but let's see what happens. Does anything reduce? So I'm going to plug in f of x, which is 3x squared, plus 1 minus f of 0. So I'm plugging in 0, and I just get minus 1, and that's all over x squared. So 3x squared minus 1 plus 1 minus 1, that's just 3x squared. So 3x squared over x squared. They reduce, I get 3. Answer is D. Okay, we've done 5 problems and we're 4 minutes and 59 seconds when I looked at the clock. Okay, so we're well within right now running a minute a problem. Very doable. Okay, now if that's the function, find the value of the derivative at 4. Let's graph it. I don't like absolute values, so I just graph them. Shift it to the right, 4 up 3. It's sitting up here at 4. I notice that I have the cusp at 4, so that because I have the cusp, I have a non-existent derivative. Okay, problem number 3. I've got a piecewise function that defines everything for all real numbers. This is a parabola, line, parabola. First of all, the limit as x approaches 2 from the left. Well, in this region, that's what I'm looking at, 2 from the left. So 2 minus 2 squared is equal to negative 2. Okay, that is true. Okay, then it says 2 from the right. I'm going to look at this piece here. So I got 2 squared plus 2. That's equal to 4 plus 2 is 6. That's true. It wants to know, is the limit at 2 equal to 6? Well, for that to be true, the left side limit must equal the right side limit. That does not, because the left hand limit does not equal the right hand limit, and that's false. So 1 and 2 are true, and the answer would be D. Problem number 4. If f of x is that expression, which of the following is false? What's the limit as x goes to 0? Well, what we do is we have to look at terms, and I'm going to rewrite the numerator as x times x plus 5, the denominator as x times, it's going to be x squared minus 25. Excuse me. So I'm going to rewrite that, x plus 5 times x minus 5. I notice now I have 2 factors that will reduce. I have 1 upstairs. So first of all, at 0, does the limit at 0 equal 0? No. It equals negative 1 over 5. So this is false. So the limit is negative 1. If I plug 0 in now, that's what I get. As x approaches negative 5, I plug negative 5 in, and I got 1 over negative 5 minus 5, which is negative 1 over negative 10, which is negative 1/10. That's true. And as I approach 5, I notice that I'm going to have an asymptote there. So that's true that the limit is non-existent. Therefore, it wants to know which one's false, and it's 1 only. Problem 5. Wants to know the limit of this one. I think we can factor out a x cubed from the numerator. That's 7x squared minus 2. Then the denominator, I can get an x cubed out of that one, and I'm left with 3x squared plus 10. So at 0, we notice that these 2 factors reduce out. And now, since both of these first initial terms will be 0, we look at the ratio negative 2 over 10, which is negative 1/5. Answer C. Problem 6. We're looking at limit going to infinity. We could use our pre-calc skills to look at the highest degree, which is 5, and then notice the ratio of the leading coefficients. Answer A. Pre-calculus problem. Problem 7. We're looking for the derivative at negative 1. So let's just go zoop the derivative, and we'll do it. The derivative of 1 over x squared is negative 2 over zoop cubed, because I'm going to plug in negative 1 here. Then I'm going to take the derivative of the next one. So 1 over x, its derivative is negative 1 over x squared. And then finally, the derivative of x cubed is 3x squared. I'm going to put a negative 1 in there. So let's reduce it. This is a negative number, negative 1. So this is a plus 2. This is a positive 1. A double negative gives us a plus 1. And this is a positive 1 times 3 plus 3. I think the answer is 6. Letter E. Problem number 8. We're looking at the derivative at 4. And we're going to take the derivative. So we're going to take f prime at joop is going to be 5 halves joop. 5 halves minus 2 halves is 3 halves. And now we're going to joop in the 4. Okay, so what do we have? We take the square root of 4, which is 2. Cube it, that's 8. And 5 halves of 8 is equal to 20. Okay, so 20, we got answer E. Number 9. Let's see, we did 8 problems plus 4 more. We did 12 problems so far. And we are 10:55 into our video. Do you notice we're doing pretty good, right? We're doing a minute. Somebody's here. Could somebody, Omar, or no, ladies, you sit on. Could somebody get the door? Okay, we might have to stop the video in a second. Not sure. Okay, let's keep going. Remember a normal line? We're doing reciprocal slope. So it says the line that's normal to the graph when x is 1. Let's take the derivative, figure out what the slope is of the tangent, which is going to be y prime at 1. At 1 is going to be 3 joop squared, put a 1 in there, minus 6 joop, put a 1 in there, minus 7. So the slope we're looking for is 3 minus 6 minus 7. Okay, that's minus 13 plus 3. That's a negative 10 slope. My perpendicular slope now is going to be positive 1/10. Once the equation of the line, now I know what the slope is. That's m. Now we're going to go with what's the y-coordinate. So y at 1 is equal to 1 cubed, which is 1, minus 3 times 1 squared, which is 3, minus 7 times 1, which is minus 7 plus 1. So the y-coordinate, what's that? I'm sorry, a little louder.
You don't need to do that. The only one on there with the slope of 1/10.
Time out. Time out. I understand what you're saying. I want to work it to fruition. I want to do a time based as everybody's going to do it that way. Okay, so now my y-coordinate is going to be negative 10 plus 2. I'm going with negative 8. Does that seem right? Okay. So now my equation is going to be y is equal to the slope 1/10, x plus 8 because it's the y-coordinate. Oh, sorry, that x plus, sorry, backing up, y is equal to 1/10, x minus 1 minus 8. Is that reasonable? Okay. Multiply everything by 10. 10y is equal to x minus 1 minus 80. So then 10y is equal to x minus 81. Let's look at our answers. Do we have a negative x plus 10y is equal to negative 81? Do we have that? No. How about if we multiply a negative 1 in there? How about x minus 10y is equal to 81? Do we have an answer like that? Yeah, we do. D. Okay, so that's that one. Okay. Now, I'm going to do problem number 10. Problem number 10. So we're taking the first derivative. That's it. Okay, so let's do this. F prime is going to be the product rule. 1, we don't want to write it. Just write 3x minus 4 plus the x. Then what's the derivative of that? 1 over 2 square root 3x minus 4. Then remember the baby, which is 3. All over nothing. All over nothing. No, that's just that we're good. Now what's the common denominator? The common denominator is going to be 2 square root 3x minus 4. Now we know we're going to have to multiply top and bottom by that, or this one here, in a form of 1. 2 times square root 3x minus 4. That means on the top we're going to have 2 times that squared, which is 3x minus 4, plus 3x. What's that? Blue screen. Sorry, it happens, yeah, every 14 minutes. Okay, now at this point, get rid of this answer, and this answer. Because you know the denominators aren't there. So let's just work on the numerator now. 6x minus 8 plus 3x. We clearly could see that that is 9x minus 8. There's our answer. C. We're done. Okay. Continue. Number 11. Derivative at pi over 4. Product rule. F prime is going to be the derivative of the first one times the second one. The cotangent of pi over 4 is what we're looking for. Plus pi over 4 times the derivative of cotangent. Opposite, cosecant squared of pi over 4. Okay, let's look at this now. What's the cotangent of pi over 4? Do your unit circle. There it is, slope's 1. Plus pi over 4 times the negative. Then what is the cosecant of pi over 4? The cosecant is the inverse of the sine. The sine there is 1 over square root of 2. So the inverse is square root 2. So square root 2 squared is 2. Now today, during the earlier period, just to let you know, and those of you that are watching this video, I screwed up on my unit circle. So therefore, by practicing my unit circle, I got these right now. Okay, so now we understand this is going to be 1 minus pi over 2. Look at our answers. There we have it. Okay, so figured I'd put that in there, Todd, since you know I screwed up my unit circle today, right? I screwed up like 6 times, right? Well, but you know I would but it was still okay. I was still okay because one time I found the answer was wrong because it didn't work. Okay, next. So what are we going to do with this problem? We got negative 1 over the square root function. That's a real hard one to graph. What do I always teach you? Square root function is what? Piecewise, correct? And when x is positive, we don't need the absolute value. The absolute value function is what I'm talking about. So let's just look at what does this function look like. This is what it looks like in quadrant 1. I'm looking for the slope at 2. All I have to do is do what? Work the function, take the derivative of negative 1 over x. So if I take the derivative of that, that is going to be negative 1 times negative 1 over x squared. That's the derivative. So I plug in 2 there. It's going to be 1 over 4. I'm looking for an answer that's 1 over 4. Letter C as in cat. Okay, problem number 13. Second derivative. Y prime is 3 opposite sine x over 3, then times the baby, which is 1/3. 1/3 and 3 reduce out. Y double prime is going to be opposite cosine x over 3 times the baby, 1 over 3. So I'm looking for 1/3 with an opposite. I got a lot of 1/3, but I got a cosine. That gets rid of that one, It gets rid of this one. And here I am, right here. Here I am. Okay, good. Okay, got it? Okay, number 14. Now we're looking at 14 is a quotient rule problem. We're going to evaluate it at 2. So let's take the derivative. Derivative of the top, 1 times the bottom. And I'm going to plug in 2 there. 2 plus 2. Okay, minus the top, which is 2 minus 2. I'm going to stop there because I got a 0 here, so I don't care to do the rest. Okay, then over 2 plus 2, quantity squared. So what's left? 2 plus 2, which is 4, over 4 squared. I think 1/4 would be the answer. B as in boy. Next problem, 15. Okay, we're going to take a chain rule problem here because it's got a big goop. Watch how I'll do this one. So f prime at negative 1. So I'm going to take First of all, 2/3, and I'm going to leave this like that for a second and just go negative 1/3. Then I'm going to take the chain rule. Wait a second. 3x squared. 3 negative 1 squared plus 2x negative 1 plus 2, just 2, and that's it with the baby. Okay. Now let's come back here and do this. We'll do the math. So negative 1 cubed is negative 1 plus negative 1 squared is 1 plus 2 times negative 1 minus 2 plus 1. Now we're ready for the arithmetic. 2/3. Hey, what's this number? That annihilates it. That's a negative 1. Okay, then what's this number? This is going to be 3 minus 2 plus 2. Okay, these annihilate each other. So what I'm left with, the 3 annihilates this one, and I'm left with negative 2. I'm going to go with E. We agree? Okay, number 16. We'll do a time check after this problem because we'll be 20 problems in after this one. Derivative of the tangent of 3x. It's a chain rule problem. F prime is what? Tangent is secant squared of 3. Then we're going to plug it in. Plug in pi over 9. That's the first one. Let's do the baby, which is 3. Okay, secant of pi over 3. The secant is related to the cosine. The cosine at 60 is 1/2. Correct? The secant then would be 2. The secant squared would be 4. Okay? And that would be that one. Now that I'm taking my time, I get 12 from the get-go, Todd. Not like today where I got, what, 4, didn't I? I made that mistake with what? Secant versus cosecant. Okay, time check. We're 22 minutes into this when we've done 20 problems. We're slightly over a minute a problem. We're budgeted for 2. We're in real good shape. We're looking for f prime at 9. I'm going to take the derivative. I like to write this as 3x raised to the 1/3. So I'm going to take f prime is going to be 1/3 something raised to the negative 2/3. And that something is going to be 3 times 9. Then I have to take the derivative of the inside, which is 3 with the chain rule. So you notice this 3 cancels with this 1/3. I now look at it. This is 27. Cube root of 27 is 3. 3 squared is 9. The inverse, 1/9. A. Now you realize I'm teaching as I'm going, right? You wouldn't be having to spend as much time because you'd be doing this without talking. Unless maybe you're somebody and then you talk. Okay, chain rule. I look at it, it's a chain rule. So this derivative is going to be 2 sine of x cubed. Then I've got to take the chain of the sine, which is cosine of x cubed. And then I have to take the baby of the baby, 3x squared. I notice I have a 6x squared outside. I get rid of this answer and this answer. I wouldn't even look at it. So therefore, I'm looking for 6x squared sine cosine. 6x squared, that's A. Okay. 18, 19. Let's go to 19. What's the value of the second derivative at the point 1 over square root 35? First derivative, 2x plus 2y, y prime equals 0. Y prime equals, get rid of the 2's. Y prime equals negative x over y. Okay, now we've got that. We could define y prime numerically. We can go ahead and plug those numbers in, and actually y prime is going to be negative 1 over root 35. Then let's take y double prime. Y double prime is equal to quotient rule. Negative 1 y minus negative x y prime over y squared. Okay, so when we look at this, we say, well, negative 1 be negative root 35 plus 1 times negative 1 over root 35 all over y squared, which is 35. Now, we're going to stop here. We're not going to have any calculator problems on the test tomorrow. However, we will need to know how to do that way. We could actually look at this number, and we know that this number here is going to be much, much, much smaller. It's a negative number, so we could eliminate these answers right here. Does everybody agree? We're literally down to 2 answers. Now, we would not necessarily be able to do this without doing the old square root algorithm. Let's go to problem 20. Okay, implicit differentiation, solving for y prime. 2y prime plus 2 times. I expect everybody to be able to do this problem with a lot of practice. Not a lot of practice, do this problem. What's the derivative of xy implicitly? Derivative of the first, 1 times y, which is the second, plus the first times the derivative of the second. There you have it. Then that equals 0. Now you notice we have 2's we could cancel out because we have a 0 here now. So I'm going to be left with y plus x, and here's my y prime. And I'm going to take this y, I'm going to put it on the other side. We should be able to look at our answer now. A negative y on top, that eliminates not all these answers. Watch it. You can get a negative y on top by this problem here. However, you notice if we brought the x plus y underneath, that's going to be this answer A clearly. You should be able to look at it and come up. Okay, we're 24 problems in, and we have now recorded for 26 minutes and 43 seconds. Again, running about what? A little over a minute a problem. Slope of the line tangent to the curve. So it only wants the slope. That's it. So let's go ahead and take the derivative. 2y prime plus 2xy plus 1 times the derivative of the inside, which is y plus xy prime. Derivative of 1 is 0, equals 0. Now it wants to know what's the slope of the line at 2, 1. So y is 1, so this is 2y prime plus 2 times 1 is 2 plus 1 is 3. Okay, this is now 1 plus 2y prime equals 0. Let's see what we could do here. We have 2y prime plus 12y prime, when I distribute the 6 to the 2, equals minus 6. So I've got 14y primes is equal to minus 6. So I'll factor that out, write it. That's equal to negative 3/7 E. Okay, 2 more to go, I think. 3 more to go. 22. You're always keeping a track. I'm going to go. You're going to have 22 problems tomorrow in 45 minutes. Keep track of your work. Don't leave the problems to the end undone. They could be the easiest problems on your test. Equation of the line tangent at 1, 7. Let's find the slope of that tangent line. So y prime is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Okay, now I'm going to plug numbers in. I'm going to do y prime at 1. So I'm going to say 3 times 1, because it's 4 times 1 minus 3, which is 1, minus 3 times 1 plus 4 is 7. 7 times 4 is 28. 4 minus 3 is 1, squared is 1. So I'm looking at the slope is going to be negative 25. Okay, so obviously, like Zach, you mentioned earlier, we could probably eliminate the 27s for the x. Okay, because now we're going to find that y is equal to negative 25 x minus 1 plus 7 equals negative 25x plus 32 is y. If I just bring the 25 to this side, I got 25x plus y is equal to 32. Answer C is what we want. 23, the line normal. Remember, perpendicular reciprocal. I mean your negative reciprocal rule for normal. It just wants to know the slope of the line normal. That's it. Line normal to the curve. Blue screen, thank you. Okay, what do we get? We just need to know what the slope is. So take the derivative. Y prime at 0 is equal to 1 over 2 square root 9 minus 0 times the derivative of the inside, negative 1. Okay, this is a negative number, and it's 2 times the square root of 9, which is then gives us 6 downstairs. Now it says the line normal. So we got to take the opposite reciprocal. So it's going to be a plus 6 is what we're looking for. Okay, last problem. The graph of the function f is shown above. At which of the values of x is f continuous but not differentiable? Okay, is continuous. It's continuous everywhere but c. So now we want to say, when do we have a cusp? We have a cusp at A, we have one at B, and then moving along we have one at E. So A, B, and E only. There we have it. Okay, let's wrap it up. 3, 31, 28, which is less than 32. Okay, you notice with all the teaching in that, you can easily see that you can do this test tomorrow, averaging 1 minute of the problem. Keep track of your work as you go along and try not to exceed that number. Hopefully this has helped.